か？
あっちだ。何か落ちたらしい。
おい、アルビン！どうした？一体何が見えるってんだよ！そんな、あの壁は50メートルだぞ！奴だ。巨人だ。壁に穴を開けられた。
Which involve the transfer of electrons from a metal to a non-metal.
What's a metal? A metal is any element with 3 or fewer valence electrons. Got it. A non-metal is any element with 5 or more valence electrons. So it works like this. If you take a molecule, sodium chloride, it's formed by an atom of sodium losing its valence electron to become Na plus sodium ion, and an atom of chlorine gaining that electron to become the chloride ion Cl minus.
The electrostatic force between the two, because they have opposite charges, attracts them to form
So,
the
Lorentz
NaCl
energy
crystal.
is the energy of formation for an ionic bond, and it's contained within the crystal itself. I have a question.
What?
Can it be quantified?
Yes. So it can be quantified by calculating the electrostatic force, which is Fe equals kQ1 Q2 over d squared. In this course, you don't actually do a mathematical calculation, so the constant, which is Coulomb's constant, is ignored. So you get the electrostatic force is proportional to the charge of the first ion multiplied by the charge of the second over the distance between them squared. In this case, the distance is the atomic radius.
Did I ask you to do that? No. Then don't do it.
Okay. I'm gonna start it.
Okay. Covalent bonding is a sharing of electrons between two nonmetals. Like,
Diatomic nitrogen has a covalent bond. Diatomic oxygen has a covalent bond. And CH4 carbon methane. Yes, methane has a covalent bond.
however, the bonds in these are actually quite different. However, we'll start with the basics of the covalent bond. In this, the carbon and the hydrogen share electrons. It has one each. Valence. Therefore, you see here that the electron pairs are shared between the two, so each of them have a complete valence shell. That's the basis of a covalent bond. Covalent bonds also only occur when the electronegativity difference is less than 1.7, so that's a very good thing to keep in mind. The higher the difference between them, the greater the ionic character of the bond. So, diatomic molecules like chlorine,
Diatomic chlorine.
yeah, chlorine gas, if you want to be so fussy. This is a nonpolar bond, electronegativity difference between them. So the electron clouds around each atom of chlorine are the same size.
They're the same size.
Thank you, Josh. However, if you take one of the bonds in carbon tetrachloride, Cl, you'll notice that since chlorine has a higher electronegativity,
It'll be.
Yeah.
this is very different from the polarity of a molecule. If a molecule is symmetrical, it will not be polar because despite the difference in electronegativities between despite each of the polar bonds, the charges balance out. No electron cloud there's no strongly negative-ish end to the molecule.
In diatomic chlorine, however, the chlorine gas, this is also symmetrical and has a non-polar bond, and it's a
A
non-polar
polar molecule would be something like water. H2O. Dihydrogen monoxide, very dangerous in large quantities, especially if you immerse yourself in it. Or HCl, hydrochloric acid. Because of the bent shape and the higher electronegativity of the oxygen, it pulls the electrons from the hydrogen electron clouds closer, leaving a tiny little one there, which makes the ends with the H's slightly positive and the end with the O slightly negative. Is it recording? Okay, go.
Fluid structures.
No, we're dead.
Our first example is carbon tetrafluoride.
It's a carcinogen. It damages your lungs,
Thank
liver,
you.
central nervous system.
Thank you.
And we have 32 valence electrons. Now we start with carbon. We
Yes.
start with carbon as the center, surrounded by. As you see, these electron pairs bonded.
Covalently.
These electron pairs bonded covalently to the carbon already make up 8 of our valence. And to complete all 32, we have to add another 6 electrons to each fluorine.
Where are you getting these electrons from?
We have them already.
We bought them.
With that, we have 24 other electrons, giving us a total of 32. Our next example is
Boron.
broke.
Boron. Trifluoride.
Trifluoride with a total of 24 surrounded by 3 fluorines on each side. That gives us a total of 6 covalently bonded things.
Electrons.
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 Now we fill in the rest of the octet for each fluorine first.
It is a total of another 18 electrons. However,
As you can see, we do not have a complete octet. This is known as, on this boron, a deficient octet.
Did Sienna steal the electrons?
She did.
Sienna!
I'm
In
sorry.
every single boron, trifluoride in the entire world.
God damn it, Sienna.
I have them all in my basement.
That's a lot of. On to the next example. We have sulfur hexafluoride with a total of, we have 48 valence. This is known as an expanded octet.
Okay.
On to our next example. We have NO3 minus with a total of 24 valence electrons.
Now we start with nitrogen in the middle, surrounded by 3 oxygen.
6
Take
of
it.
our total of 24 already. Now if we begin to fill in the rest, we have used another 18 electrons. However, we already have a deficient octet. To solve this, we take away from any one of the oxygens a pair of electrons and create a double bond. This is known as resonance.
This isn't like boron because nitrogen has 5 valence electrons and enough lumen.
However, you can also write this as all of these represent the same exact molecule. Instead of having a single bond to each of the oxygens, we have a 1 1/3 bond to for each.
Since the bond cycles between these three forms. Is that loud enough?
That is correct. Now we have resonance. Yeah.
Molecular geometry. Josh, give her a high five. That was lame.
At some point,
Now this is the arrangement of atoms relative to the central atom. The first one we're going to do is linear with a bond angle of 180 degrees, and it looks like that. You can
The Baymax face, if you will.
with 0 lone pairs, 2 bonded pairs, and 2 electron pairs. An example would be Cl2. Now,
Look at him
let's do
struggling. Look
trigonal.
at her slightly struggling.
Struggling so much. Trigonal with. What a planar your face.
She went there.
I'll snap.
No snap.
I'll snap.
Trigonal planar. With
120.
0.
What about the bonding? No, it cannot be in radians.
Trigonal by pyramidal.
Pyramidal.
That's what you.
Pyramidal. Trigonal bipyramidal.
Not bisexual.
now it's just a matter of these things.
Hey, that's what she
Angles of
said.
90 degrees and 120.
Why does it have two different bond angles?
The reason it has 2 different bond angles is because of the position of the different bonded pairs.
Bam.
Bam.
There are
Once enough people
electron pairs.
We done.
Go away, Jason.
Jason, get out. Okay. Ooh, all the garbage done.
So each of these molecules have bonds. Nitrogen,
Oh my god.
It's still going.
Yes, it's still going. Where'd you go?
This
Oh my god.
You put like a seed.
Here, I'll hit the button.
Oh no, it's on. It's on.
On the floor.
Geometry.
Molecular geometry. Josh, not an M.
Friends the other day. The universe is created from protons, neutrons, electrons, and morons.
They meant morons.
They meant borons.
What?
Say hi, Mr. Truscott.
Hi, Mr. Triskin.
Yes. Is that a dad joke?
You told me what to say, so I said it.
What if it has 4?
Shut up.
Okay.
Coulombic attraction, and so a stronger ionic bond than two elements with tiny charges and a huge distance between them.
Does that mean the bigger molecules are
No, it doesn't because molecules are covalent bonding.
It's the dream.
Yes.
Okay.
Hit the board.
No, I'm not hitting it.
Geometry.
Geometry! Dude!
Yo!
Remove yourself from
Josh, get up, you big loss.
He's a daredevil. No sense of self-preservation. We predict the species will go extinct.
Yo, try with no hands. Say no hands, ma.
Definitely extinct.